In this video, we will look at visualize the words with TensorBoard. Let's play a little with TensorBoard. This is TensorBoard. In the center, we have a representation of the data based on principal component analysis. Here we have a variance explained, the higher the better, but this is not our data, so let's use our data, the data that we produce with TensorFlow. We have an embedding, and then the metadata, that again are the labels of the words. And here, in the search tab, is the funny part. We can type a word and we will get the list of its neighbors, so we can understand if our clusters are good or bad. Let's start with food. Here we have a regular expression list, but we click here. Okay, and these are the neighbors: chicken, lamb, salt, meal, coffee. Well, a very logical cluster, and a very good cluster, of course. So it looks like we are doing a good job. But let's try another word, for example, sports. These are the neighbors: sport, of course, NFL, soccer, teams, football, players, Carolina, ball, athletes. Again, very logical and very good cluster. Food and sport are topics. So, what happens if I type the name of a person, for example, Obama? Well, we have democracy, powers, Obamas, nuclear, Trump, borders, leader, president, Trump's, labor, inept, administration. Okay, this cluster does not look that homogeneous like the others, but still we can see that there's a logic behind it, and politics looks like the main idea behind these clusters. Okay, good job. Before moving forward, let me give you some advice. The more data you add, the better the cluster. The problem is that sometimes you require a lot of computation to get good clusters. The clusters depend highly on the corpus on which you build the embedding. If you look for general purpose clusters, you should know that there are pre-trained public embeddings such as the following. But what if I want the observations with their cluster assignment? In the embeddings, I have the neighbors, but I don't know how many clusters do we have. A very quick solution can be to use our embedding matrix as an input for classical techniques such as hierarchical clustering or k-means. Let's go back to code and try k-means. We import sklearn, the k-means module, and run it. The clusters are ready. Let's assign it. Okay, great. We have Trump, people, wood. You see something quite interesting. President goes with the same cluster as Trump. You remember our TensorBoard neighbors? Okay, so let's get the groups with the word president. Okay, it's the cluster 91. Okay, we can assign it here, and we see what are the members of this group. Okay, we have Trump, president, Trump's, Obama, vote, voters. Great. They are not exactly the same words as we had before, but maybe it's quite more logical. I don't know. But it's a good cluster. There is logic behind it, and there is a main idea, which again is politics. Let's print our metadata with the groups. Okay, let's play again with TensorBoard. Now we are back to TensorBoard. This time we have one more column in the metadata, that is the group assigned by the k-means algorithm. What can we do with this? Let's first load the data. We have the embedding space and the metadata with groups. We just found out that the group corresponding to the word president is the group 91, and that matches politically concepts, somehow like the group Obama in the previous cluster analysis. Now, looking at the right, we see that we have another option, which is the option group. We can choose the group. Let's choose group 91 then. Here we have the words corresponding to the group and to the nearest neighbors. Okay, so for example, here we have that some words in the group 15 are similar to the group 91. Let's check what do we have in the group 15. We see that we have delusional, constitution, so somehow similar words. Another interesting option is that we can choose groups here. So let's switch to group 92. There we go. And here we have the group corresponding to food: sweet, heating, coffee, cup, lamp. Okay, that's all with TensorBoard. Let's recap what we have done. First of all, you have to create good embeddings with TensorFlow. Then you use these embeddings to visualize and explore the clusters in TensorBoard. You switch them to classical techniques and assign cluster with k-means or hierarchical clusters. Then you mix the output of classical techniques with TensorFlow approach in TensorBoard, and you can compare them. That's all. See you in the next section, in which we will build a machine translation system.